Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk to you about how to set up a systematic grid mooring analysis for a finfish aquaculture system in ProteusDS. So what we're going to do is use the sample system designer file of a real fish farm, the Liverpool setup file, and what this will do is show you how System Designer works to configure all the details in a grid mooring system. So we have parameters for the site, water depth, and number of cages. There's lots of other settings for the different kinds of containment nets and also the material properties that you can select for them or create new ones depending on the kind of nets that you have, compensator buoys, and of course the moorings as well. Now there's a scope and a sag parameter. The sag we find correlates very well to pretension based on the the weight of the chain that you have in the system. And like I said, there's lots of details in here, but we're just going to go straight to exporting this to create the ProteusDS simulation toolbox project. So we'll go to export, and we'll need to make a folder to save this. So what I'm going to do is call this initial setup. And we'll just call this farm. Okay, so what System Designer has done for us is created the ProteusDS simulation toolbox project. And you can see if we open the pre-visualizer here, I'll just make this a little bit bigger. So there's our farm. Can show the water surface for reference there. So we have all the cages as we specified in an array with the bridle lines, compensator buoys, and all the mooring lines as well in the seabed. So we're going to assume that the sag value that we've specified is going to give us the pretension we want. You'll be able to check out how to adjust pretensions in another video tutorial. But what we really need to do as part of a systematic process is evaluate what happens to the farm in currents and waves. And this systematic process starts with a steady deflection of the whole system in current, and then a superposition of the wave load effects on that. But it's not just one case. Usually standards require evaluation of the mooring loads in many different weather headings as well. So we want to show you how to do that. So we're going to close all of this right now, and what we need to do is get the help of another application called Case Explorer. So ProteusDS Case Explorer is specifically designed to help go through the process of configuring all of the different load cases with weather in different headings for a particular farm system. So we'll go New. And what we need to do now is select the Proteus simulation toolbox file. So here I've got farm. And it's pretty standard to do 8 cases, and we'll just go with the standard 8 cases right now. And what I find helpful is if we switch the view here at the bottom to fish farm NS9415, because you just sort of follow the process a little bit more with current speeds and then waves later. So we're going to use the same current speeds through the entire all different headings, but you could specify different values individually, and you can put them in manually here, or actually specify them over here. Hit Control A to select everything, and then the values that you specify will apply to all of them. So we're going to use custom current profile, and that gives us an option here of specifying 0.3 for the surface speed and 0.15. Now these are arbitrary values. You're going to have values for your own site, but you can see how it's populating there for you. And then the upper depth for the first reference point is going to be 5 meters depth, and the second one is going to be 15 meters depth. And so we've configured all the current information here. Now we want to make a couple of other adjustments here, particularly to simulation time and the output interval. The first step in evaluating the static deflection of these systems, we're going to use a dynamic relaxation process. So it's running a dynamic simulation, but just with steady current, and we'll see what happens to the system. So 300 seconds is pretty conservative for a length, but what that does is you can always check on your simulations as they're going along. It's a little bit trickier to restart them or continue them. This is usually well more than enough time to reach steady state. Sometimes with tricky bathymetries and certain circumstances, it can take a little bit longer. But so 300 seconds will capture that. With the output interval, we'll set it to 1 second because we don't really need a lot of fine detail, and then it'll go a little bit faster because there's not as much file I/O as you go through this process. And yeah, just checking over everything here. I think we've got everything set up all right. So we'll go save. And what I want to do is we're saving the Case Explorer file here. So I'm going to call this current cases. Save. And now what's happened is we have a folder here that's been created, current cases, and every single variation, if you look for the farm file in here, every other project with the farm file has been generated for us. So if we just look at this, you can see here we have the custom current profile information, and the associated heading is included. In this case, it's the column, this extra column of the current profile information. It's all generated for you and ready to go, which is nice. Now the next question is, how do I run all these? Now you could run them individually in Proteus Simulation Toolbox, but it's pretty painstaking process to go through each one and set them up. So what you can do instead is using this other program, ProteusDS Queuing Manager. You simply drag and drop the files in here. Select the number of simulations you want to run. It depends on how many cores you have and how many threads you can run on your computer. We'll run it and then check on the results to see how they're going. The other thing you can do is you could zip up these files and then copy them onto another computer you have dedicated for running the cases, with potentially more computational power, more simulations you could run in parallel. So that's all for now. Thanks for watching.